And then I would like to invite our third of salt intrusion, and currently he is working at Nelen and Schuurmans, where he is specializing in radar, rainfall forecasts and information enhancement in wastewater networks, and he will talk about Generation Next.
Yeah, we did some hustling with the titles and the speakers, so my apologies for that, but yeah. I think the presentation will inform you the way it is right now. All right. Yeah, I want to inform you about ControlNEXT. Let's first figure this out. There, all right. It's lazy. All right. ControlNEXT, and it's a new framework for real-time control. So I'm happy that I'm the third speaker, because the speakers before me gave actually a real good introduction about what real-time control actually is. And I'm not going really into figures and numbers like that, but I'm really trying to explain what this new framework is. Well, as I told you, I'm Gevers Deynoot, and I'm working for Nelen and Schuurmans. Can the arrow maybe disappear, or is it? In the right, thank you. So we're here in the session with modeling and advanced control. Well, as you can read for yourself, creating the possibility to predict the behavior of water processes and the interactions in the water cycle to improve operations with respect to water quality, costs and environmental emissions. That's a lot. Well, one way to do that is to use real-time control. And why do you use that? I will go into that. And I will go into the specifications of ControlNEXT. What is ControlNEXT? What's special about it? And does it actually work? Because you see a lot of simulations and testing and numbers, but does it actually work? That's an important part of the whole solution. Back to the basics, because we heard some terms and what is what, but real-time control, you have a situation, for example, at your camping site. If you have real-time control, measurements are done, and well, usually you won't see inundation like this, because if a system works, it will pump away the water, but you do measurements. Then there's a pump with a PLC, and by now you know what a PLC is. It has a little control algorithm, and it will make sure that that the pump starts pumping, and as a result you have happy campers. This is if you have a local control cycle. Because it will measure, for example, upstream water level, and based on the upstream water level and the control algorithm, the pump will start working, and it will measure its result. But then it's only for a local situation. And yeah, right now we're in times that local steering is not enough. That's why also in Amsterdam it's for a larger network, and it's an integrated system. Why is it not enough? I don't know where to point at, actually. So what do we see? I got this from the RioNet site, and it shows actually calculations we do for the design of a sewer network, and which is in the bottom. It says bui 8. It's a duration, depth duration graph. You probably know these kind of graphs. And if you do design of sewer networks in Holland, we work with the bui 8. But actually, if you see extreme events like in Apeldoorn in June 2009, if you design a sewer network based on bui 8, you can see that what happens in Apeldoorn is too heavy load for your system. And in the last month, I met some people, and they gave me some examples of the last year. in other cities where also extreme events happen, and they actually witnessed it themselves. So they said, okay, new times for new systems. So there's water quality and quantity issues as a result of those extreme rainfall events. We just heard about sewer overflows. What happens is investments in infrastructure in your sewer network. Are those effective investments? Well, we can question that, but we can install a real-time control system. And what do we expect? Well, we already heard that. We can do some cost saving, higher efficiency and less investment in infrastructure. So also greater environmental benefit. If we reduce overflows, we get better water quality, stuff like that. And with the RTC system, we can handle disturbances in the system better. So, for example, extreme rainfall events. If we know that these events will occur, we can already empathize on that. In Dutch, we say meten is weten. It says if you measure, you know what you're going to get. Sometimes you have extensive studies in areas, and they do measurements and they make analysis, and then they give you a report and they say, well, this is how it works, and good luck. So in Holland we say, well, if you measure twice, you know for sure. And it's even better if you do continuous monitoring and you collect your data real time and you know what's happening, because every time there's an extreme event, you can use that as a lesson and see how your system actually works and performs under these extreme events. So then we get to the ControlNEXT part. Why ControlNEXT? Well, ControlNEXT, you already see the logos in the bottom. It's actually some sort of community, and we work together. And it's a cooperation, and it's development by different institutes. We work with academics from the TU Delft. It's a university in Delft, a technical university. We have researchers, people from Deltares, and his name actually was on the list, Klaas-Jan de Hart. And we have people like myself, consultants from Nederland Schuurmans, who together work on this platform and this community, which enables and integrates real-time control in a larger perspective. What is a good thing about ControlNEXT? It has a really open structure. So if there are new developments, they can easily be implemented in the system. So you can actually develop your system and make it better as you go. Well, what's special about it? A good thing about ControlNEXT is that it has a modular setup. We heard about the local real-time control networks, and well, from the government on, it's initiated that municipalities and water boards work together. Well, there are municipalities who have their own real-time control network or databases, but it's really hard for them to work together, and also with the water board share data. And with ControlNEXT you can actually take those databases, put them together like those Lego blocks. Also integrate, for example, weather forecast or different other applications, and make them to one big system. And also if you want to add some control algorithms, you can actually add it to the system. Basic functions of the ControlNEXT system is you can import the data, you can validate it. We already heard that sometimes there's data with peaks. You can erase them from your system, put a flag on it. This is unreliable. You can modify your data, regulate, and then you can steer by sending back what your control algorithm comes up with, send it back to the existing telemetry system, and then control your system based on those control algorithms. Now, for example, really basic picture for the people who are not really fond of letters. What happens is you have a system with a bosom canal or little canals, and all this data of water levels is collected in a SCADA system. So all data is available. What does ControlNEXT? ControlNEXT actually reads the data, what is in the SCADA system, combines it, for example, with meteorological forecasts. And right now we're working on the energy market, how to implement energy costs and the market into this system. And based on that, with control algorithms, actually steer and regulate the objects which are in the RTC network. So what can we do? We can connect with numerous data sources. It's applicable to multiple SCADA systems, so different municipalities can work together even though they do not have the same database. And what else? We can steer on energy. So if it's in Holland by night, you have cheaper rates. It's preferred to pump at night and not at daytime. So we figure out, or ControlNEXT can figure out, hey, is it useful to pump by day, during the day, or is it better to wait till it's dark and we have cheaper energy rates and maybe fill up the system a little bit, but then pump at a lower cost. Yeah, since 2011, the energy market changed its structure. Before we had day-ahead rate, so big consumers, they used to already say, hey, the next 24 hours we're going to use this much energy. And since the beginning of 2011, you can also on the day itself say, hey, right now the prices are low, so we want to use it, and we're gonna pump. So actually, this is a new import for a control algorithm. You can say, okay, we can pump at night, we can pump when the water level is high, but we also can pump when the market says, hey, we have low costs. So that makes it really, really dynamic, and with the right control algorithm, you can really work with that. So, features of the ControlNEXT system. There's an interface. It works with Delfuse. It's developed by Deltares. And you can actually see all your data. It comes from the database. You can see it on a map. But there's also, you can create a simulation environment. So if you have certain control algorithms running, but you want to improve and you say, hey, let's try a different algorithm, you can create this simulation environment and actually in this simulation environment run all your control algorithms or your new control algorithms without interfering with the operational system. 2 minutes, nice. Also you can do knowledge discovery in databases, also known as data mining. So old data, you can run it through a new algorithm and see what happens. So if you have existing systems or new algorithms, get your data from the years before and run it through the new control algorithm. And in this way you can see, hey, maybe if we would have implemented it earlier or in the future, we will have better results on the control of our network. Well, this is what it looks like. We have rainfall, we have a load on the system, and this is what you get. You get a new level of your water levels in your system or in your sewer network. Well, an important part of it is, does it work? Yes, it does. Because it's not only a bunch of talking. We actually already implemented it, and it has pretty nice results. We implemented it in the water board of Hollands Noorderkwartier. They use it for surface water systems, for water quality and water quantity control. This is actually almost the province of North Holland. And right now we're doing these areas, but we're working on control algorithms for the whole water board. What more? It's implemented for the Hollandse Delta, for a wastewater system, to optimize the use of the sewer network, but also the loads during extreme events to the water treatment plant. And this area, I think it's comparable to 3 times Amsterdam North, and it's a combination of 5 municipalities and a part of the whole water board. And then there are several municipalities who also use it for local control of their local sewage network. More information you can find on the ControlNEXT site, .nl, or without the dash .org. And it shows more, and you can read more about what it is about, who are part of the community. So before my time is over, I want to conclude. We do RTC for cost savings and higher efficiency, to make better use of your existing systems. But what is the surplus of ControlNEXT? We use the benefits of real-time control. But the important thing is the modular setup. We are able to connect to different SCADA systems, so we can really enhance the cooperation between different municipalities and the water board. And it functions on top of operational SCADA and telemetry systems. So it's not a telemetry system itself, and we can just plug in the existing systems without any further costs or modifications to the systems. There's room for improvements. We have a simulation environment, so you can test whether new control algorithms really improve your network. And it's adaptable to new insights. So if you say, hey, we have a new algorithm, you can test it, and without interfering with the operational system, you can test it or implement it, and you're set. So that's it. Thank you for your attention.
Thank you for a very nice overview of ControlNEXT. Do we have any questions? Yes, please.
ControlNEXT sounds like a product name. So the question is it really a product? I mean, it's dependent on taking into account all the peculiarities of the environment you're taking care of. So two questions. One is, how difficult is it to take it from here and bring it to a different scenario? And what is the business model? Is it that you sell the software and the algorithms, or that you sell the kind of service to collect all that data and do the evaluation? So it's a kind of reoccurring service revenue stream coming over.
Well, there's different parts to it. With the control algorithm, you can actually control your network and your system and the behavior. So this is something that you develop really with the user, and all the knowledge from the area goes into in the development of those control algorithms. If you want to know what the business model is, you can actually meet with Klaas-Jan de Hart. He's from Deltaris. He's sitting here, or Fons Nelen. He's from Nelen Schuurmans, and they are downstairs at the lunch break. So I have to direct you to them. But if you actually want to cooperate with different parties, with different databases and different systems, the ControlNEXT can actually be your umbrella over the system and make an integral improvement of your RTC network. Does it answer your questions?
Okay, we have time for one more question.
Your system seems like an information management system.
Mm-hmm.
In a remote location, right? You connect to different SCADA systems, different treatment works. I'm assuming that actually how to collect the information from different SCADA systems can be quite challenging, because they're linked to the hardware, because the treatment work they build at different time period, and then there's a system that not always compatible. So that's the technique challenge. So my question, in your presentation, you said there's no problem to plug in. What is actually a technical solution for you to make sure that the protocol, that the data, you can collect the data from different work, the treatment works? That's number one. The second thing is also, when you collect the information, sometimes it's not only the technical issue, there's the mentality issue as well. People sometimes, quite often I would say, not willing to share information with you. How you can convince your future customer to do so?
Thank you. So there's two questions, and I think your second question is about mentality. If you don't have the mentality, I can answer your first question by saying it's never going to work. Because if you don't open up your data sources, yeah, you won't get in. So the mentality should be, okay, let's cooperate and let's work together. And that's something that was also shared during presentations earlier in the other room. You have to be willing, and in Holland it's encouraged to open up your data sources and actually cooperate. So that's about the mentality. If the mentality is there, and you want to plug in different data bases, you have to be willing to open up, and that's just a technical part. You with the right protocols and opening up firewalls, and it's just a technical thing. You have to be willing to do it. But once you get in, you have a different time series and different kinds of data, and that's, you have to really intensively work together to see, hey, what do you actually collect, and is it any good? And with this ControlNEXT system, you can actually change or aggregate to different time series intervals, so you can make the data compatible to each other. And you can do that in this system. It's based on Delft Fuse, developed by Deltares. So you can use different time series intervals and connect it, and also different regions. You can plug it all together. So it's a technical thing which can be solved with Delft Fuse.
So it's some sort of a standardization. You try to standardize different input over time.
Yeah, and there's this standard which is encouraged in Holland to use Aquon. You can use that. If you use that, you know if it's cubic meters per second or rainfall per hour, whatever. And if you use that, it's easier to actually connect and work together.
Okay, thank you. Let's thank our speaker once more. And I would like to invite